This video will show you how to use a built-in performance shaping factor, or PSF, in the Improved Performance Research Integration Tool. IMPRINT stands for the Improved Performance Research Integration Tool. It is a manpower, personnel, and training prediction tool owned by the U.S. Army Research Laboratory and developed by Alion Science and Technology. It is freely available to U.S. government employees and contractors. For this video, I'm going to show you how to open a library model, save it to your computer, review the missions, functions, and tasks, and run it for baseline mission results. Then I will apply one of the built-in IMPRINT performance shaping functions that impacts task accuracy, run the model again, and compare baseline mission results with the stressor applied results. I will use a library model of a CH-47D cargo helicopter for this video. If you have IMPRINT installed, you can follow along. We will go into IMPRINT, open the model from the start page, save a copy on the computer, and look at mission criteria. This is the start page that you see when you first open IMPRINT. We are going to open a library analysis, so I need to expand the IMPRINT library section of the start page by clicking the down arrow. Now I can see all the libraries and models included with IMPRINT, and the icons to the right show me what types of missions are included in each analysis. I want to find the analysis called Cargo Helicopter CH-47D and open it. Once I locate the model, I just click on the name, and IMPRINT will close the start page and open the model. You can see that my analysis tree has been expanded, and the operation models node has also been expanded to reveal the 4 operational missions. The first mission, named Fly from Assembly Area to Pickup Zone, is displayed beneath the operations model node. If I double-click that node, the mission description window will open. From here, you can view or edit the mission name, description, and mission criteria. On this example, the mission name is Fly from Assembly Area AA to Pickup Zone PZ, and the description is displayed below. The mission criteria consists of the time, accuracy, and mission criteria. Here, the mission must meet the criteria of 55 minutes, 85% of the time, and must complete without abort, 85%, and must meet the mission time and accuracy criteria 80% of the time. Now I will save a copy of the library analysis on my computer by selecting Save As from the File menu. And then I will give it a name, CH-47 PSF, and click Save. Each operational mission in IMPRINT should have 1 or more warfighters defined. These are the entities that perform the tasks. In this model, there are 4 operators defined: co-pilot, crew chief, model task, and pilot. The operator named Model Task is an automated operator that is assigned to any task not performed by a human. It does not accrue workload. The others are all non-automated and perform tasks during the missions. You can view the operators by expanding the warfighters and operator nodes in the analysis tree. In IMPRINT, to view the defined operators, expand the warfighters node by clicking the plus symbol, then expand the operators node by clicking on that plus symbol. Now I can see my 4 operators, and I can see that my pilot is my default operator. This means that for any new tasks, this operator will be assigned to perform the task by default. If I double click on model tasks, I can see that this is automated as true, and all of the task management strategies options are unavailable. By double clicking on co-pilot, I can see that automated is false. He is a human operator, and he is the specialty type of officer, and he has a workload threshold of 60 with no workload strategy defined. Now we will look at the mission components and task diagram to see what functions and tasks are performed during a mission. You can either click on the Mission Diagram tab in the descriptor window, or you may select this window using the View menu, Windows, and Network Diagram. In IMPRINT, expand the mission by clicking on the plus node next to the mission name. Notice that you can now see all the components of a mission. If I select the Network Diagram tab in the center, I can see the functions and tasks that have been defined for this model. In the task diagram, functions are represented by gray rectangles and tasks by rounded rectangles. The top level of this mission has a start task, an end task, and several functions. If I double click on the start task to open the task description window, there are 8 tabs in here. I can see on the first time and accuracy tab that this is a 0-time task. By clicking on the crew tab, I can see that this has been assigned to my automated operator Model Tasks as the primary operator. So to close the task description window, just hit the X in the corner. To view any task within any function, just double click on that function. So if I double click on Communicate here, a new network diagram tab will open that will display all of the tasks within that function. You can go into each task like I did for the start task to view and edit task parameters. Or IMPRINT also provides a grid view where you can quickly view and edit any task data. To open the grid view, just double click on the network node in the analysis tree, just below the mission name. You can also customize what fields you see on the grid. Here's my network node below my mission name, so I'll just double click on it to bring up my task grid. Up at the top you'll see 5 tabs: Review Tasks, Review Functions, Review Scheduled Functions, Review Goals, and Diagram. We want to look at the Review Tasks tab, so I'll leave it at that. Below that there's 3 radio buttons: Task Info, Task Demands, and Warfighter Assignments. Right now Task Info is selected. If I scroll to the right in the grid, you can see there's all kinds of data displayed. Everything about the failure probability, the timing, the taxons. I can customize that by right-clicking on any header and turning on or off things by clicking the check mark. I can also right-click, and there's a More button that you probably can't see right now, but that'll bring up the display columns thing, so I can just turn on or off any individual columns by double-clicking in those fields. I can also change the order by moving things up or down using this dialog. Going back to my grid view, I'm going to scroll over to probability of success here. If I scroll down through my tasks, I can see not all of them are 100%. I've got some that are as low as 3 or 1% even. So that means that some of my tasks are probably going to fail. Second, let's go over and look at our fail probability. Some of those are above 0. That means that there is a potential for the mission to abort and fail. Third thing we want to look at is, does this model have taxons assigned? And yes, it does. So we're in good shape there. I'm now going to run the model 100 times and look at 2 of the reports, the mission performance and the mission results by run reports. Before running the model, it's always a good idea to check for errors by clicking on the check mark on the toolbar. IMPRINT will check the model and report any errors in the output window. If there are no errors, it will report no errors found, simulation created successfully. Next, open the execution settings by clicking the check mark on the toolbar. From here, you can set the model to run 100 times. So it is set at 10, so we're going to go ahead and change that to 100. To run the model, just click on the play symbol on the toolbar, and the output window will display when every task is completed. Once all 100 runs are done, all of them will be reported in the output window there, and I can see that it'll say simulation complete. To view the results, simply go up to Reports, select Operations Results, and IMPRINT will bring up a window that lists all available reports. We want to select Mission Performance and Mission Results by Run. Click OK, and IMPRINT will generate the reports in Excel. In Excel, each report has its own worksheet and is labeled on the tabs at the bottom. From the Mission Performance report, I can see that over 100 runs, 97 of them were successful. That means that 3 failed. So if I go look at my Mission Results by Run report, I can see which ones actually aborted. So I can see run number 6 aborted. If I scroll down, run number 26 and run number 39. Now we are going to apply a built-in PSF to the model. For our example, there is concern about the cargo helicopter's vertical stability. It is feared that in some conditions it could exhibit periods of high frequency but low magnitude vertical vibration. This would be similar to a ground vehicle moving quickly on rough terrain. We are interested in predicting the impact of this condition on mission performance using the IMPRINT performance shaping factor named PTS vibration. We are ready to apply the built-in moderator to the model and determine the impact of the moderator on overall mission success. To do this, we need to tell IMPRINT which PSF to enable, which tasks the PSF will be applied to, select the PSF parameters, and enable the PSFs during model execution. In IMPRINT, open the PSF window by clicking the Performance Shaping icon on the toolbar. From the Settings tab, you need to specify what moderators you want to apply. We want only the vibration one to be checked, so make sure everything else is unchecked. From the Settings window, I can also enable PSF adjustments. This turns on the PSFs for the entire model run. The vibration PSF impacts tasks, so now we need to go to the Task tab and tell IMPRINT which task to apply it to, and then enter the moderators. So we want to enable our PSF for all the tasks. So a trick to doing this would be to select the whole entire column and then clicking anywhere in that column. And now you'll notice all of my tasks are enabled. So now we're going to go back up to the top, and we want to have a high frequency and a low magnitude. We want to apply that to all the cells, so an easy way to do that is to select both the cells, right click, say copy cells, then select all the tasks, all the rest of the tasks, go down, right click, and say paste cells. So now you'll see that my moderators have a high frequency and a low magnitude for all tasks. We are ready to run the model. Once again, we will run it 100 times and open the mission performance and the mission results by run reports. We're going to check our execution settings before we run the model. So we're going to go in here and make sure that we're running it 100 times, and that we also want to make sure that we have PSS adjustments on. Those are both true. So now to run the model, we just click the play button from the toolbar. Once again, the output window will show you the results of the runs. Now once it's finished all 100 runs, you can see in the output window that the reports from all of them are shown there. Now we can go up to the reports menu, select operations results, look at our two reports we want, the mission performance and the mission results by run. Click OK to tell IMPRINT to generate those reports. Once they're generated, it'll bring up Excel. So now we can see that our mission was only successful 80 times. That means it failed 20 times. If we go to the mission results by run, we can see the first run failed, the 9th one, the 11th one, and if we scroll down, so we had a lot more mission failures than we did in the baseline model. If we compare the results in the mission performance report from the baseline to the moderator runs, we can see that the number of successful missions went down and the number of failures went up. In the baseline, we had 97 successful missions and 3 failures. With the vibration stressor, we had 80 successful missions and 20 failures. This is because the vibration PSF made the task accuracies lower, which in turn made the mission failures increase. The mission results by run shows you which missions failed. We can see that 20 runs were unsuccessful. Thank you very much for viewing this video. If you do not already have IMPRINT and would like a copy, please contact ARL using the super long email listed here. Happy modeling!